Friction. It's that resistance we feel when we slide two objects against each other. We all have an intuitive understanding of it, but probably don't pay near enough attention to it. So, how does it work and why should we care? Let's find out on this episode of The Science of Safety. If you don't want this to happen to you, or this, it might help to learn a little bit more about friction. So, super basic physics lesson. Here we go. Let's say we have an object and a flat surface. Depending on what those two things are made of, they have a certain level of friction between them, and it will require a certain amount of force to move the object against the surface. Why? Because at the tiniest level, the bumpier the objects are, the more they will collide with each other when force is applied. Not to mention, at an even tinier level, the molecular bonds that are at play. But that's not the whole story. The weight of the object also matters. On a flat surface, the heavier the object, the more force will be required to move it. Now, this isn't rocket science. We all get that things generally slide easier on smoother surfaces, and that a heavier thing is harder to move than a lighter one, at least on a flat surface. But let's dig a little deeper. Did you know there are actually two different kinds of friction? When I push on an object and it's not moving, that's because something called static friction is pushing back. Not this kind of static, but static as in staying still. That static friction will actually resist me equal to the amount of force I apply, right up until the object moves. Static friction is what gives us that grip when we walk or drive as we propel ourselves forward. Basically, we aren't typically slipping because we aren't exerting enough force to overcome the static friction. Now, once the object does start to slide, that's where a new kind of friction comes in. Kinetic, meaning movement. Basically, you've applied enough force that static friction has lost the battle, and it's been pushed beyond its maximum limit. So, now things are moving. But you are still getting some resistance. That is the kinetic friction. The important thing to know about kinetic friction is it's weirdly a smaller value than the maximum amount of static friction, meaning that once the object is moving, it requires less force to continue moving it. Now, that may be helpful if you're moving furniture, but it also means when you start slipping, it's harder to recover. But that's still not the whole story. There's also something called the normal force, which is perpendicular to the surface the object is on. Now, as an object presses against the surface, the normal force pushes back an equal amount. How much does the object press against the surface? Well, that's determined by the object's mass and gravity. Specifically, how strong the gravity is and the direction it's pointing relative to the surface. The thing is, when objects are on a slope, gravity is no longer pulling the object only against the surface. It's also partially pulling it down the slope, which means this here isn't as strong as if it were like this. It might seem strange that surfaces are actually pushing back against us, but if the normal force didn't exist, we'd basically be sinking into every surface we came across. The last piece of the puzzle is something called the coefficient of friction. Basically, there's a whole scientific table out there where smart, sciencey people have experimented to figure out how easily different surfaces slide against one another, and they assigned a number value to each combination. That is the coefficient of friction. So, for instance, a ski on snow has a much lower coefficient of friction than rubber on concrete. Okay, so let's lay it all out. You have the force you exert on an object. You've got the friction pushing back, which is determined by the coefficient of friction between the surfaces, and the normal force, which is determined by how much the object presses against the surface. And that is determined by the mass of the object and the strength and direction of gravity. Great. How do we use all this to keep us safe? Well, when we're out in the world, we can't always control what a surface is made of, but we can control what's on our shoes and tires. Rubber, matched with most surfaces, has a pretty high coefficient of friction, and it gives us a solid all-around option to give us grip. But if you look at the bottom of your shoes, or car tires, it's not just one big slab of rubber. Why? Well, The treads on your shoes and tires are designed for two reasons. First, tread helps to dig into soft or uneven surfaces, sort of creating friction at a macro level. Remember when those tiny surfaces were bumping into each other? Well, with tread, that effect gets magnified. You can even look at cleats, spiked shoes, or snow tires and see that they help us dig into surfaces rather than sliding across them. Now, the second reason for tread is rain. Once things are wet, the amount of friction decreases significantly. You see, it's no longer just rubber and asphalt. Now, there's a layer of water in between, which decreases the coefficient of friction by a lot. Luckily, those channels you see on your tires and shoes are designed to help move water away so that the rubber has better contact with the surface. But when the tread is worn down, those channels disappear, meaning there's a lot more water between the rubber and the road. Wearing the right kind of footwear or using the best kind of tires for the job and making sure the tread isn't worn down makes a huge difference in preventing slips, crashes, and injuries. But hang on, we're not done yet. Remember earlier we said the other part of friction is weight? Well, as we walk and drive, the weight is constantly shifting, meaning that moment by moment, we're increasing or decreasing the normal force, making the points of contact between us and the road have more friction or less. On a normal day, we can trust that our shifting weight isn't going to affect friction enough to make us slip, but on ice or slick surfaces, that's a different story. So, how do you beat it? Well, the easiest way is just to avoid slick surfaces when you can. If it's icy out, maybe make other plans. But if you can't, try to be aware of where you are applying pressure or force. Ideally, you want it more downward than out. When walking, taking small steps and keeping your weight consistently over your feet ensures the maximum friction possible. This also applies when driving. Think about where the weight is shifting in the car as you drive. Hitting the brakes too hard shifts the weight to the front, creating less friction on your back tires. Add a turn, and you're setting yourself up for a spin. If you accelerate too fast, your weight shifts to the back, reducing the friction on your front tires and potentially spinning you again, just differently. Smooth acceleration and smooth braking helps keep the weight more evenly distributed. Add in smooth turning and lower speeds, and you'll avoid applying too much force in any direction. Remember, avoiding a skid is a lot easier than trying to get out of one. While slipping can be fun in some situations, it can be dangerous in others. Wear your proper footwear. Make sure your tires are in good condition, and think about the shifting weight as you're walking and driving. We'll see you next time on The Science of Safety.